Hello everybody! I can graph functions by typing the equation into the calculator and using scale is greater than or equal to the maximum divided by the number of boxes. This is day 2 of this, or not day 2, but part 2 of this. I recorded part 1, and now we're going to move into the 6-point questions. I'm going to go over maybe 3 of them with you. You'll do the rest on your own. So let's start with number 9. I think the other video was supposed to be numbers 1 through 8. I'm going to kind of clear some space. These things take up a lot of space here. So, a company is considering building a manufacturing plant. Great. Nothing mathematical there. Let's move on to the next sentence. To determine the weekly production cost at site A to be this equation, and site B is this equation, where X represents the number of products in hundreds, and AX and B of X are the production costs in hundreds. So everything's in hundreds. It wants us to graph them. So I'm going to go to my calculator. I'm going to go to Y1. I'm going to type in 3x squared, and then Y2, 8x plus 1. Now we need to know what we're going to be graphing between. Most of the time it will tell you whether it's in the problem or on the graph. If it doesn't, then you're going to have to do your whole zoom fit thing to get a nice picture. But usually they're going to tell you, and they're telling us on the graph. The graph goes from 0 to 4, so that's what I'm going to be graphing between. So I'm going to want to copy down the table for A of X and B of X from 0 to 4. And again, these are 6-point questions, so yes, they're going to be a good amount of work. Doesn't mean they're necessarily that hard. In fact, I don't think this is hard as long as you know how to do all the little components. So I go to my table, and I'm going to copy down the tables from 0 to 4. You can do this on your own. It's going to take me a little bit because I have to go back and forth. I can't have the calculator up at the same time as writing it down. So, you can just kind of do this as your own while I'm doing it. 12, 17, 3, 27, 25, 48, 33. And now you want to pay close attention to scale if it gives it to you. So in this case, it's giving me a scale. It has numbers on the axis already. You still have to determine how much each box is worth. But when they don't give you, you have to come up with your own scale. That's when we utilize what we did in that last lesson. So it looks like every 5 boxes is worth 1 on the x-axis. That's pretty straightforward. And on the y-axis, it looks like 5 boxes is worth 10, which would make each box worth 2. Now, understand for these graphs, and again, same thing with the first half, the points aren't going to be perfectly on corners. They just need to be between the appropriate boxes. So I'm going to start with A of X. I'll do A of X in blue. 0, 0, that one's pretty easy. I'm going to make this bigger so it'll make it a little bit easier for me to graph. 1, 3. So 1 on the x-axis, and then 3 is between 2 and 4, so it would be right there. 2, 12, 3, 27, 4, 48. That would be the box under 50. And we don't draw arrows into the axis, but we do draw arrows if it's going not into an axis. So that's A of X. Let's go to a different color. Let's go green. And let's do B of X, 0, 1 would be right there between 0 and 2. 1, 9, 2, 17, 3, 25, 4, 33. there's p of x. All right, so we graphed it. We got a lot of points so far, and now we're probably going to have a follow-up question. State the positive value of x to the nearest tenth for which the production costs at the two sites are equal. If I want to know where they're equal, I'm looking for the intersection point. Can I see the intersection point to the nearest tenth on here? I mean, I see the intersection point. The intersection point, is right there, but I don't know exactly what that point is. So I learned how to find the intersection. We learned how to find the intersection points in the calculator. Now, normally we go to zoom 6 and adjust the window, but I don't have to adjust I do have to adjust the window, but it's really easy because I know that my x's are going from 0 to 4 and my y's are going from 0 to 50. So I'm just going to go to my window and have my x's go from 0 to 4. And I'm going to have my y's go from 0 to 50. That way it'll give me the same picture that I have there. To find the intersection point, second trace, option 5. We did this in a previous lesson. Again, there's a lot of little components for these questions, but as long as you know all the little components, it's really not bad. Enter, enter, enter. It was asking for the x, the number of, actually, let me just double check that. So, it wants the positive values of x to the nearest tenth. So that would be 2.8. Explain how you determine the answer. 2.8 was the x coordinate for the point of intersection. If the company plans on manufacturing 200 products per week, which site should they use? Now, here's a little twist. 200 products per week. So X is the number of products in hundreds. So I'm not plugging 200 in for X. I'm plugging 2 in for X. So where X is 2, it represents 200 products. So they want to spend less money, not more money. So the blue A of X would be better. You can kind of see it on the table here. So site A, because it costs 1,200 instead of 1,700. That's it. It's a 6-point question. It's a lot of work. There's a lot of components to it, but we typed the equations into the calculator. We saw that it wanted the tables from 0 to 4, so I copied down the tables from 0 to 4. I plotted the points. I answered the follow-up questions. To find when two things are equal, you're finding the point of intersection, and we learned how to do that in the calculator with the second trace menu, and then asked another follow-up question, which I was able to do. You could have also plugged 2 in to the equations to get the 12 and the 17, but it's easier to just pull it from the table or from the graph. All right, let's move on to number 10. So this was a 6-point question on the algebra 2 regions. I think this is one of the easier ones that was asked on the algebra 2 regions. Not that they get hard, but there's really very little twist to this one. It's a very straightforward one. So we're going to just kind of read through and kind of go from there. Website popularity ratings are often determined using models that incorporate the number of visits per week a website receives. End of sentence. They didn't really give me anything important there, so I'm going to move forward. One model for ranking websites is P of X equals log X minus 4, where X is the number of visits per week in thousands. P of X is the popularity rating. All right, so I have an equation, and it's telling me what the variables represent. X is visits in thousands, P of X is popularity rating. It's saying that the website is visited 16,000 times. So visits is X in thousands. So if it's 16,000 times, then I'm substituting not 16,000 in for X, but 16 in for X. Because it says that X is in thousands. So I'm just going to plug in 16 minus 4. This might be one of the easiest points you can get on the algebra 2 regents. I'm going to type in log of 16 minus 4. It wants me to round to the nearest tenth, 1.1. I think that's 2 points. I mean, what a joke. I think if you plugged in 16,000, you got 1 point. But, I mean, you're just substituting in like you would do back in 7th grade. I'm going to erase this now because we're going to need some more space for what we're going to be doing. But that's the first component of the question. So now we're going to move on. It wants me to graph it. So graphing's easy. I go to my calculator. I go to y equals. I type in log x minus 4. There's no log base here, so I do regular log. Now, if you look at the graph, it's giving you the scale, which makes this even easier, and it goes from 0 to 20, so I know that I'm going to want my table to be from 0 to 20. I don't need to plot all 20 points. Also notice that everything's positive here, so I'm going to disregard anything negative. So let's see what I'm working with in my table. I have errors at 0, 1, 2, 3, and 4, so I'm not going to plot those. I'm going to plot 5, 0. That's going to go in my table. I'm not going to plot 6, 0.30103. There's no need to do that. These are all yucky numbers, so I'm not going to deal with them. I'm going to plot 14, 1. Only plot the nice numbers, but make sure that if the table ends at 20, make sure that you include 20. In fact, I think that's all we're going to get. 20, let's call it 1.2. It's giving you the scale, so you don't have to worry about doing scale is greater than or equal to max divided by the number of boxes. So the X scale is a little tricky here. Every 3 boxes is worth 2. So when I want to plot 5, 0, 5 is in between 4 and 6. So it's going to kind of be in between these 2 boxes. So that is a little bit of a twist, but you know, it is what it is. So 5, 0, and my pen just stopped working, which happens sometimes. 14, 1. That one's pretty simple. And notice that, you know, on the y-axis, every 4 boxes is worth 1. So just, you know, pay close attention to that. 14, 1 is going to be right there. 20, 1.2 is going to be right there. It's a curve. I don't draw an arrow into the axis, but I do draw an arrow out, and I'm going to label this as P of X. All right, let's see what else we got to do here. An alternative rating model is represented by R of X equals blah, 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 blah. X is still number of visits per week in thousands. It wants me to graph R of X. Okay. I'm going to go to Y equals. I'm going to pop it into Y2 in case I need to do like an intersection or anything later on. Alpha Y equals enter. 1/2 X minus 6. Again, I'm still going from 0 to 20. So I'm going to just erase what I have here. And I'll do this in green. This is going to be R of X now. Again, because the graph goes from 0 to 20, those are the X values I'm going to look at. Now, if you notice, 0, -6, I can't plot that because I don't have any negatives in this real life situation where everything's positive, so I'm not going to plot the negative points. I'm going to wait till I get to some positive points and 0. So 12, 0 can go in my table. And then I can put, I'm not going to put 13, 1/2 because, why would I? I don't need to do that. I can do 14, 1. I'm just going to plot the nice points, 16, 2, and 18, 3. And I believe we're going to have 20, 4. It's a line, so, it has a consistent slope. All right, so now I'm going to plot these points, 12, 0, 14, 1, 16, 2, 18, 3, 24, that's R of X. All right, I just got more points. I feel like I haven't done anything difficult yet. I've just been plotting points and I substituted something in. For what number of weekly visits will the two models provide the same rating? So same is the point of intersection. And I have the point of intersection here. The point of intersection is 14, 1. It wants weekly visits. Weekly visits is X in thousands. So it would be 14,000. Will students lose a point because I write 14 instead of 14,000? I'm sure that some of you will do that. Obviously, read it carefully and you won't make that mistake. But overall, I thought this was a very, very nice 6-point question. You're just popping the equations into the calculator. You're copying down the tables. Again, it's telling you to graph from 0 to 20. So that's what you're doing. You're pulling the tables. You're not plotting the nasty points or the negatives. And then you're answering the follow-up questions. All right. I think I'm just going to do one more with you because, a lot of the stuff is just important to just practice. I can do this one, but I think I want to do... you know what? Let's do number 12. This was a 6-point question on one of the first out of 2 regencies. One of the a little bit harder than some of the other ones, so that's why I want to go over it. I'm going to make this a little bit smaller. I like to keep the graph big to make our life easier when we go to graph it. I'll deal with it later. All right, so drugs. It's always good when a math problem starts with drugs. Drugs break down the human body at different rates and therefore must be prescribed by doctors carefully to prevent complications such as overdosing. That's great and all. Anything mathematical? No. The breakdown of a drug is represented by, here you go, N of T equals N0 e to the negative RT, and it tells you what the variables represent. N of T is the amount left in the body, N0 is the initial, R is the rate, T is hours. Patient A of T, is given 800 milligrams of a drug. Well, that's N0. With a decay rate of 0.347. So e to the negative 0.347 T. Patient B is given 400 milligrams. So N0 is 400, and the rate is 0.231. So the negative 0.231 T. Write two functions, A of T and B of T, to represent the breakdown. We just did that. Graph them. So we're looking for what we're supposed to graph between. Do I see anything on the graph? No. Do I see anything in the problem? No. So we're going to have to come up with our own picture using the calculator. That's what makes this one a little bit more tricky. And to be honest, I think this is the only Regents question where it didn't tell you what it wanted you to graph between. Usually it does, but this was, I think, the only one where we didn't. If you remember to type in E, it's second, and then the ln button. Negative 0.347. X, instead of T, we use X. And then I have 400 e to the power of negative 0.231. So let's start with zoom 6, because it's not telling us what we're graphing between, so I kind of have to find a picture in here. And zoom 6 gives me nothing, which I knew it would, because 800 and 400 are the initials, which is not going to fall in my standard window. So I'm going to try zoom fit, which is zoom 0. And that looks better. It's not great, so let's just take a look. I have a lot on top which I don't need. So I'm going to make my Y max 0. Instead of 25,000, let's like cut that to like 10,000. Let's just see if that makes things better. Also, if you want to use a little bit of common sense, being how the y-intercepts are 800 and 400, maybe making it a little bit bigger than that would be a good choice. So I'm actually going to change it to 1,000, which is a little bit bigger than 800, which is the biggest y-intercept. And since they're both decaying, that should give me a better picture. Now, notice that the graph, there's no negatives, so I'm going to adjust my window, and I'm just going to make it my x-min 0. And let's see what this thing looks like. I think that looks good. I see my intersection point. I think that's going to be fine. So my window, my x is from 0 to 10. So that's what I'm going to copy down. I'm going to copy down from 0 to 10 for both. So I'm going to do n of t and a of t. I'm definitely getting a little scrunched on space here. In fact, I don't think this is going to work out too well for me space-wise, but we got big numbers. Now, these are all kind of nasty numbers. So I'm just going to plot, I'll definitely do 0, 800 and 0, 400. And I'm just going to plot like every other point. So I'll do 2, I'll round that to the nearest unit, 2, 400. I'll do 2, I'll do 4, 6, 8, 10. 2, 4, 6, 8, 10. So 2 is going to be 400 and 252. And 4 is going to be 200 and 159. And 6 is going to be 100 and 100. And 8 is going to be 50 and 63. And 10 is going to be 25 and 40. All right, so let's get a new color here. Let's go red. Now I got to deal with my scale. So I'm going to just create myself some space here and Get rid of the equations at this point. Now I need to come up with scale. So my scale, which we did a whole lesson on, is greater than or equal to the max divided by the number of boxes. So let's do the x first. The maximum x value is 10. The number of x boxes is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 10 divided by 20 is 0.5. Is 0.5 nice to work with? Yes, because 0.5 means that every other box is worth 1, so I'm going to go with 0.5. You could have made it 1. You could have chose anything that's bigger than 0.5 or equal to 0.5. We want it to be easy to work with, but close to 0.5. 0.5 is great, again, because that allows me to make every other box worth 1. My y's now. My maximum y value is 800. The number of y boxes, I believe, is 20 as well. It is. I'm not going to physically count on the thing for you because it's a little messy right now, but it is 20. You can count in your own paper. 800 divided by 20 is 40. Is 40 a nice number to work with? Yes. So I'm just going to use that. If you wanted to use 50, that's totally fine. You might want to use 50. So my x's are going to be 0.5, my y's are going to be 40. So if you want to like write this down or pause it, because I need to erase it so I could actually get this stuff up there. So at this point, again, to create some more space, I'm just going to delete this. My scale is going to be 40. I'm going to erase all of this. And again, I like to label every other box. So each box is worth 40, so I'm going to label every other box, which will go by 80s. 160, 240, 320, 400, 480, 560, 640, 720, 800. Now I'm going to plot the points. Let's get some different colors. I'll do n of t first. 0, 800. 2, 400. Oops, right there. 4, 200. 4, 200. 6, 100. That's between 80 and 120. 8, 50. 10, 25. I don't draw arrows into the axis. But that one's not hitting the axis, so that one will get an arrow. That is A of t. Now let's go a different color. Oh, I'm sorry, that's n of t. And now let's go purple for A of t. 0, 400. 2, 252. A little bit more than 240. 4, 159, just under 160. 6, 100. 8, 63. 10, 40. That's going to be A of t. All right, so again, this one was a little more complicated. We had to find our own picture in the calculator. We had to then create our scale based on our tables, which we did a whole lesson on. So if you're not comfortable with the scale, go back to that video. Now, I'm sure we have some follow-up questions. To the nearest hour t, when does the amount of the given drug remaining in patient B begin to exceed the amount of the given drug in patient A? Well, one exceeds the other instantaneously after they're equal. So we're looking for the intersection point. Now, I rounded with these values, so I'm pretty confident that's going to be 6. But it could be 6.1, it could be 5.9, it could be 6.2. So I'd like to do it the right way. I'd like to go back to my calculator, second trace, option 5, enter, 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 and I get 5.97. It asked me to round to the nearest hour, so that would be 6 hours. So that's the answer to the first question. The doctor will allow patient A to take another 800 milligram dose of the drug once only 15% of the original dose is left in the body. So patient A, it would be nice actually to have that little blurb back. So here, let me get that little blurb back. Whoops. Let me just pause it for a moment. And magically it's here. So patient A, oh yeah, I did mess up on the graph. I'm sorry, it was A of t and B of t. So let me get that back. I messed up the labeling, that's my mistake. So the green was A of t, the purple was B of t. It's hard to work on this one little screen and on this complicated question. And we had A of t, B of t. All right, so now we're talking about patient A can get another 800 milligrams once 15% of the original dose is left in the body. So patient A's original dose is 800, and again, we talked about percents. If we want to know, if we want only 15% remaining, it's not increasing or decreasing by 15%. There's 15% remaining, so we're going to multiply 0.15 times 800. And I'm just going to use my calculator here. 0.15 times 800 to get 120. So once 120 milligrams are left in his body, then he can get another dose. So this is the amount remaining in his body. So we're going to replace 120 with A of t, 800 e to the negative 0.347t, and it's asking for nearest tenth. So does it say determine algebraically? No. So you have two options. Option 1, you can do it algebraically, or option 2, because it doesn't say to do it algebraically, I'm going to just do y1, y2, intersect. Since it doesn't say to do it algebraically, you're not going to get any additional points for doing it algebraically. You can get the same amount of points doing it graphically. So I already have that 800e in here. I'm going to change my y2 to 120. I think I already worked with the graph before, so I'm not going to mess with the window. I'm looking for that intersection, second trace, option 5, enter, enter, enter. It wants the nearest tenth of an hour. That's my x value. So to the nearest tenth, that would be 5.5 hours. I guess as a math teacher, it would be nice for me to solve this algebraically. So I will do it algebraically now as well. So here, I'm going to erase this at this point and just solve that equation. But we're done with the question. I just want to show you how you would do that without using y1, y2 intersects. But again, you would get full points for using y1, y2 intersect in this example, since it does not say to solve algebraically. So if I'm solving this algebraically, it's an exponential equation. So my first step in an exponential equation is to isolate the base. 120 over 800 is 0.15. So I get 0.15 equals e to the negative 0.347t. Now, since there's a variable in the exponent, I do the log of both sides. And since it's an e, I'm going to do ln. That just makes my life a little bit easier, but it doesn't matter if you do regular log or ln. The reason I do that is to bring the exponent in front. And ln of v is just 1, so it just kind of cancels. If that confuses you, again, you could, when you divide in your next step, you could divide by the ln e as well, but it doesn't affect anything. It'll just kind of cancel itself out. I get t equals alpha y equals enter ln 0.15 over negative 0.347. And I get the same answer I got when I did it graphically, 5.5. I think it's easier to just do it y1, y2 intersect, but it's always good to practice this algebraically. That's it. So listen, these are long questions. Some of them have more twists than others, but I mean, to graph something, you type it into the calculator. It usually gives you what you're graphing between. For example, if I take a look at the next one, this one I'm graphing between 0 and 10, so I'm going to copy on the tables from 0 to 10. I need to make my scale. Scale is greater than or equal to the maximum divided by the number of boxes. We did a whole lesson on that. So if you're not comfortable with that, go back to that lesson. Plot the points. You answer the follow-up questions. They usually ask you for the intersection point, y1, y2 intersect if you're doing it in the calculator to get the intersection point. But the follow-up questions can really be anything. So we're spending a lot of time on this. These are, again, common 6-point questions on the regents. Your classwork / homework is to finish graphing functions, and you will have a 1-question quiz once you're complete with it. Have a great day.